Okay, so this week we've done some revision of all the trig we've seen so far this year. Now this lesson's just going to be a bit of preview about stuff for next year. So all I want you to do is just listen to the examples, make a few notes, and then try a few questions yourself. Yeah, if you can't get any right, don't panic because we'll go through it in more detail next year. So just to start off, if we were asked to solve this equation, so sine 2 theta, I've used x, haven't I? Sine 2x equals cos 2x, where x goes between 0 and 180. Hopefully, you would spot that if we make a substitution, y equals 2x, so then y goes between 0 and 360, just times the interval by 2, then we get sine y equals cos y. Then if we divide both sides by cos y, we get tan y equals 1, which we can solve by doing inverse tan of 1, which gives us 45 degrees. And then we can add 180 to that to get 225 degrees. So there are answers for y. So y equals 45 and 225. So x, well, x is just y over 2, so 22.5 and 112.5 degrees. Yeah, hopefully they'll do that from your revision. Now, if I changed the question to this, so it's not a 2x anymore, it's just an x, think, why can't I still use the same technique? Why can't I call that y? If y was 2x, then x would be y over 2. So again, the angles would still be different. I can't divide by cos because sine 2x over cos 2x doesn't equal tan of anything. Like nothing there makes sense. So we need a new formula to help us do that. So we'll come back to this in a second, but the new formula is this. So this is the first one I wanted to write down. It's going to be 3 sine 2 theta. So sine 2 times an angle is equal to 2 sine theta. But I also have times by cos theta as well. Now you'll see where that formula comes from next year. Okay, so that's a formula that you're going to have to learn. But again, don't worry about it this year. Next year we'll do it. So I can use that formula to write stuff like this. So if I had sine 4x and I want to rewrite that, well, to use this formula, I want this 4x to be 2 theta. Yeah, so I can use it. I want these two things to be the same thing. So that means theta, then either theta, would be divided by 2, so 2x. So I can rewrite sine 4x as 2 sine theta, which is 2x, cos theta, which is 2x. Okay, let's try the same thing but with a 6x. So sine 6x. Again, I want this thing here to be a 2 theta. So to get theta, I would divide by 2, so it's 3x. So I get 2 sine theta, which is 3x, cos 3x. So hopefully you spot a bit of a pattern now. And in fact, these formulas are called double angle formulas, because look, the angle just gets doubled. 3x turns to 6x. This 2 at the front always stays as a 2. Okay, I can use this formula in reverse. So for example, if I had sine x cos x, and I wanted to write it as one thing, well, look here, sine theta, well, straight away I've got that x equals theta. So 2 theta would equal 2x. So I don't want the 2 there, so I can divide this side by 2. So sine x cos x is a half sine 2 theta, which is 2x. Simple as that. Okay, let's try 4 sine x cos x. Well, again, x and theta or the same thing, that's what I want. That means over here, 2 theta would be 2x. Now, I want it 4 this time, but I've got 2 there, so I need to times this side by 2, so I need to times this side by 2. So I would get 2 sine 2 theta, which was 2x. So just give that. Okay, and one more, then we'll go back to that equation. I had sine 3 theta, cos, actually let's stick with x, sine 3x, cos 3x. Okay, well this time I want theta to equal 3x. So 2 theta would equal 6x, so times by 2. So over here I would have sine 6x. But look, I don't want it 2, so I have to divide both sides by 2, so I'll get the half sine 6x. Now we'll do an example to see why that's important in a second. Okay, so if we go back to our original question which I was asking you, so between 0 and 180 of sine 2x equals cos x. Well, I've got an identity to use now. So here, look, 2 theta is just 2x. And that means theta is just x. So I can change sine 2x into 2 sine x cos x. And this side is going to stay the same as cos x. And now you should be able to spot what we're going to do. I can't cancel out these cos x's. Instead, remember, I take them over to one side. Make it equal 0. I can factorize out a cos x. And I can solve them separately. So cos x equals 0. Well, you know how to solve that. Arctan would give arccos, would give you 90. 360 minus that would give you 270, just outside the region. And this one, 2 sine x equals minus 1 equals 0. So sine x equals a half. So you can do arc sine, so x would equal 30, and take that away from 180, so that's 150. Yeah, so you can use solve in your calculator to check and line to you. Yeah, so look, we use the double angle formula there, and then as soon as we get everything into the same angles, that's when we can use our tricks from the first 2 lessons. Okay, one more sine one, then we'll look at the cos one next. So let's do radians this time. So from 0 pi, let's do one more, work backwards. 6 sine x cos x equals 1. Well, I've got a sine x and a cos x, and I've got a 1 that side. If that was 0, it would be easy. Since it's a 1, there's nothing I can really do, so it's one trig function. Now, I can't divide by cos, because if I divide by cos, the side would become a sec, which wouldn't help. Sine equals sec wouldn't really help. So instead, I can use this double angle formula. So here, I've got sine x cos x. Here, I've got sine theta cos theta. So x is just theta. So that means 2 theta is 2x. But here, look, I've got a 2, but I want a 6. So I have to times this by 3. So I would times this by 3. So this side becomes 3 sine 2 theta, which is 2x, equals 1. Now I can solve it the normal way. So I would say 2x is y. So then it goes between 0 and 2 pi. So I have 3 sine y equals 1. Divide by 3 to get a third. And use a calculator, make sure it's in radians. And arc sine of a third gives us 0.3398, blah, 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 blah. And then we take that away from 180, which is pi, so pi minus answer gives us 2.8017, blah, blah, blah. And then to get x, where's x? To get x, it's y over 2, so these were y answers. So we divide these by 2. Let's do answer by 2. Second one is 1 point, do 3 significant figures. First one is 0.170 to 3 significant figures. Yeah, so as soon as we get it into this form, so as soon as we get to this step, it's just like all the other stuff that we did this week. It's just this first thing of combining the sine x and the cos x using the double angle formula. Okay, so that's the sine one. The next one is cos one. So the formula for cos is cos 2 theta equals cos squared theta take away sine squared theta. So look, double angle to that, and the same rule would work before. So for sine 4x, it would be cos squared 2x take away sine squared 2x. Cos 10x would give me cos squared 5x take away sine squared 5x. Okay, so I'm not going to do any rearranging of that. I'm going to jump straight into questions. And let's start with between 0 and 360. Let's go back to degrees now. We have cos 2x equals cos x. Well, looking at this, I've got different angles, and this one's the double one, so I want this one to be 2 theta. So 2 theta is 2x, so theta is just x. So I can't change cos x, but I can change the double angles. I can change cos 2x by using this. So I get cos squared theta, which is x, take away sine squared theta, which is x, equals cos x. Okay, now look here, I've got a cos squared, cos x, I've got a sine squared, that's ruling the padding. So I can do the sine squared, is I can change sine squared into 1 minus cos squared x. Okay, expand and simplify, so cos squared x minus 1 plus cos squared x equals cos x. So I get 2 cos squared x minus 1 equals cos x. Take it all over to one side. So 2 cos squared x minus cos x minus 1 equals 0. And now look, it's just a quadratic in disguise. So if I make y equal cos x, then I get 2y squared minus y minus 1, 0. So solve that on your calculator. And we should get 2 minus 1 minus 1. We get pi equals 1, y equals minus a half. Sub back in what y was, so cos x equals 1, and cos x equals minus a half, and solve in the normal way. So from this one I get 0 and 360, and then not in the range. And this one, let me just double check what that one is. We get 120 and 240 in there in the range. And again, use solving to check that if you don't believe me. Okay, so again, this step looked tricky, but as soon as I use the double angle formula there, this could have easily been a question from year one. Yeah, get everything in terms of one trig function, make it quadratic, because we know they normally turn into quadratics. Okay, I want to do one more like that. So let's still have between 0 and 360. And this time I want to see if you can spot why I'm trying to trick you with this. I've got cos x and sine x over 2. So there's no 2x. However, if you look here, look, x is double x over 2, isn't it? So it is a double angle formula, so I'm still going to use cos 2 theta, but I want 2 theta to equal x, this one here. This is my double angle, so that means theta must be x over 2, which is that bit there. So if I use the double angle formula here for cos x, so I get cos squared theta, which is x over 2, minus sine squared theta, which is x over 2, equals sine x over 2. Okay, now it looks a bit like the equation before. Now what I'm going to do this time, before I start rearranging it, is that I don't like writing angles like this. I'm just going to say y equals x over 2 So I'm going to change the boundaries to 0 and 180. So then this equation just takes y squared, cos squared y, take away sine squared y equals sine y. Okay, so I've got a sine squared and a sine and a cos squared. So I'm going to change the cos squared by using 1 minus sine squared y minus sine squared y equals sine y. So I'll simplify 1 minus 2 sine squared y equals sine y. Take everything to one side. 2 sine squared y plus sine y, and y put 2 y's there, minus 1 equals 0, which we can solve. Oh, sorry, that's a quadratic in disguise. Look, if I use, I'm going to use, let's use t. If I said t is sine y, then I get 2t squared plus t minus 1 equals 0. It's a quadratic. So t equals a half, and t equals minus 1. So sine y equals a half, and sine y equals minus 1. To solve it, and we're doing y between 0 and 180. So sine y equals a half. That gives us 30 and 150. And sine y equals minus 1. Well, that has no answers between 0 and 180, because the first answer is 270, and that's outside the range straight away. So there are answers for y. But we want x, and x was, well, y equals x over 2, so x must be 2y, so x is 60 and 300. Again, that one was tricky because I used two substitutions. I used y to get rid of x over 2 and t to get rid of sine y. Okay, so we looked at the sine double angle and the cos double angle. Now let's have a look at the tan one. Now the tan one looks the trickiest, and this is the one we have to use the least, so it's good. So it's a fraction, and it's 2 tan theta over 1 take away tan squared theta. And again, you could do the same things with tan 10 theta would be 2 tan 5 theta take away over 1 take away tan squared 5 theta. Yeah, so this angle is always double these angles. Or equally, you could say that these angles are half this angle. Now I'm just going to do one example for this. So let's do the example. Let's use y. Let's make it go between 0 and 2 pi to go back to radians. And the question is 2 tan 2y times tan y equals 3. Well, straight away, you can see I've got a double angle. So this is my double angle. 2 theta equals 2y. So that means theta equals y. So I can use this formula to change this term here. So I get 2 lots of 2 tan theta, which is y, over 1 minus tan squared theta, which is y, times tan y equals 3. Well, I can just expand that out a little bit. But 2 times 2 is 4. Tan y times tan y is tan squared y, over 1 minus tan squared y equals 3. Times both sides by the bottoms, times both sides by 1 minus tan squared y, run out of room. So let's go to this side. 4 tan squared y equals 3 lots of 1 minus tan squared y. Expand, so 4 tan squared y equals 3 minus 3 tan squared y. Well, I've got tan squared y's, so I can just take the tan squared y to that side. Or if it helps, again, let's make a substitution. It's called t tan y. So t squared is tan squared y. So then we have 4t squared equals 3 minus 3t squared. So we get 7t squared equals 3. And we're now room again with my writing. So let's finish this bit over here. So if I divide both sides by 7, like t squared is 3 over 7, square root. So I get t is root 3 over 7, or t is minus root 3 over 7. subtract in what t is. So tan y equals root 3 over 7, tan y equals minus root 3 over 7, and then solve and multiply further. So inverse tan, I'll make sure I'm in radians first. Inverse tan of root 3 over 7 gives us 0. Let's do 3 significant figures, 5, 8, 4. Add that to pi, it's 3.7. Actually, let's do 3 decimal places, 371. Then this one, well, my first one gives me minus 0.587. Sorry, 580. To add pi to that, 2.562. That's not in the regions. I can add 2 pi to that and get 5.744. So there's my 4 answers for y. I've told you the time one was a bit trickier, but see if you can follow it, because just algebra, as soon as you get rid of this first step here, into that, then it's just algebra after that. So like I said, I don't mind if you find this a bit confusing. It is a bit confusing to begin with, but have a go at some of the practice. So question 4 is a bit more straightforward, and question 5 gets a bit trickier. Now before that, there's a table I want you to fill in just with this sine double angle rule, just so that you can have a play around with changing the angles. So let me know what you get stuck on.